Hi everyone and welcome to the part second of API gateway pattern. And in this we'll just talk more about why we need API gateway, what all functionalities API gateway is providing for our applications. These things we already talked about. What are the common challenges if we are not using API gateway? We have to take care of authentication, authorization, logging. These need to be implemented with each services, and it's like a duplication will happen if we start doing this on each and every service. Okay, it is difficult to make changes in a particular microservice because the session is active, and if we change it then it will disrupt the user session. Okay, functionalities of API gateway, what all it is providing to us is all these. On API gateway you can put all these things there. Okay, authentication, authorization, service discovery, integration, response caching. So API gateway is taking the response from multiple services. You can enable the caching so that response will be faster if the same request is coming. Retry policies, circuit breaker. Okay, rate limit and throttling. If a particular client is making too many calls and it may bring down your particular service, then you can just put a rate limit and throttling of request per second a particular client can make. Okay, it is helping us to enable the identity providers authentication and authorization. These things are true for AWS API gateway because it is providing all these things. API gateway is providing load balancing, logging, tracing, and correlations. Okay, with the help of API gateway, you can actually do the IP whitelisting. Okay, you can take care of the headers, query strings, all these coming from the clients. Okay, so these are like basic things we get from the API gateway, and there are many anti-patterns of API gateway. Okay, sometimes what we want is backend for front-end clients. Okay, so sometimes what we want is a different set of backend for individual API front-end. Similar like mobile client will have its own mobile APIs, web client will have its own web APIs. In that case, we can have just a single entry point. These mobile API will, so this is actually customized version of it. So this is actually considered as a separate pattern in the API gateway pattern is where every client need to have its own API backend. Okay. So what all different API gateway implementation we have like Kong. Kong is one of the vendor. What are all it is providing monitoring, caching, access control, authorization, rate limiting, authentication, all these things, access control, right? Which are very important. Caching, monitoring, rate limiting, throttling, authentication, authorization, logging, tracing, right? All these things are provided by the API gateway. And API gateway is sending your request further to the microservices we have, right? So if you talk about AWS API gateway, how it works is you have different things. We have just AWS API gateway you create on the AWS console, and then you can connect to either Lambda or your HTTP backend services which are running somewhere. You just do the HTTP mapping on the API gateway. You can also have a WebSocket service enabled on the API gateway, right? All these things are available on the AWS API gateway, and all the other services coming from the client, coming from the mobile, from the desktop, from the web, from the IoT, anywhere can talk to the API gateway. It's a one single entry point. Okay, and then API gateway can talk to either your EC2 instance, maybe a Lambda, maybe a particular service running on the Kubernetes cluster or anywhere. Okay, so this is how AWS API Gateway works. What are other implementations we have like AppDizzy API Gateway, MuleSoft, Swagger Hub, Azure API Gateway, Express API Gateway. All these are actually different implementations are available. You can choose whatever you want. I mean, I commonly use AWS and Azure API Gateway, which is easy to implement through their consoles. Okay. Now on the API Gateway pattern, what we can do is API composition and aggregation, right? Why it is helpful API composition and aggregation means is we have API gateway which is again going to talk to multiple services and get the data. So API composition can happen at the gateway level to aggregate the response coming from the multiple services and combine them and send this data back. So that kind of implementation provided by GraphQL set of API gateways. If you are creating GraphQL API gateway, it can actually fetch the data from the multiple microservices in Node.js or any other programming language, So here we are doing composition and aggregation. Okay, this is the API gateway. If we just talk about this one single flow for API service 1, client API service 1 talking, this is the API gateway talking to the microservice. This microservice can be talking to multiple microservices because sometimes microservices are dependent to get the data from other third party or remote services, right? So in that case, we can just check this API composition. Okay, so this is what we have for the our API gateway pattern. Like these are the different implementations we have for the API gateway pattern, and these are the responsibilities that API gateway need to deliver for our application. Currently, if you use the AWS API gateway, then you might create an authorizer or authorizer with a gatekeeper, which will just authenticating your token, or you might be using some identity provider like Google or OpenID Connect, all these kind of identity providers. API Gateway also providing this load balancing, logging, and routing. All these things are available onto the this cloud vendors. Like we are using AWS API Gateway, which will have all these features enabled, or you can use Appizy. Okay, so let's talk more in the next video about other microservices patterns. Thanks everyone.